Hello, fourth graders. Welcome to another week of Number Talks. We are spending one more week with doubling and halving. And we're going to look at is third and tripling. We're going to look at quadrupling. We're just going to realize whatever you do to one number, you're going to do the inverse to the other. So in other words, if you're doubling one number, you're going to half the other number. So think about it. You're multiplying that by 2 or you're dividing by 2. Maybe you're multiplying by 3, you're dividing by 3. Maybe you're multiplying by 4, divided by 4. Whatever allows you to manipulate the number so that it can allow you to find the answer the easiest way. Also, remember this week on our learning ops, I've included another 3 problems. Challenge yourself to go above and beyond. Those problems are not part of this week's learning strategies, but it is an opportunity for you to think critically. All I did is I took last week's problems and I just extended them this week, so they're very similar. And next week I'll be changing it up so that piece of it, the challenge yourself to go above and beyond, will be quite different actually. But just to let you know. So let's look at 16 times 7. If we think about doubling and halving, well, we know that 7's an odd number, so we don't really want to have that. But what if we doubled 7? That would be 14. If we halve 16, that would be 8. If we halved 8, that would be 4. If we doubled 14, that would be 28. If we halved 4, that would be 2. If we doubled 28, that would be 56. If we halved 2, that would be 1. Double 56, that would be 112. I don't really have another way to show it to you personally. I think that's the most efficient way in terms of doubling and halving. Now, 15 27s. Well, they're both odd numbers. So it's like, well, wait a second. If I half either one of them, I'm going to get a fraction. So what if we said, well, what if we tripled one? So what if we did thirds and tripling? So let's look what happens. What's 15 divided by 3 would be 5. 27 times 3 would be 81. And then if we think about that, 5 81s is 405. If you want to take the extension of that, double 5. 5 doubled is 10. Half of 81 is 40.5. 10 times 40.5 is 405. Or think of it another way. What if 15 times 3 would be 45. 27 would be divided by 3 would be 9. 9 45s would also give you your 405. So you can really do the tripling, the tripling in thirds in either direction, and it works out. Now, 25 times 48. Well, what's neat about this one is, think about, what if I multiplied 25 times 4? That'd give you 100. And then if I took 48 and divided it by 4, that would give me 12. So then I know 25 48s must be 1200. Now, if you said, well, Mr. Harrison, I wouldn't have seen it that way. Maybe you just took it and said, well, I'm going to look at it as a doubling and halving. So I'm going to double 25. That's 50. Half of 48 is 24. Double that, that's 100. Half of 24 is 12. Again, that's going to still give me that answer. So these are a few different ways you can look at it. Just remember, the inverse operations, whatever you do to one number, so if you're multiplying one number by 4, then you divide the other number by 4, then you're going to be having the same value. Okay, if you divide one number by 5 and you multiply that number by 5, again, the value doesn't change because you're using inverse operations. So if you're confused by this process at all, please ask a teacher or come see me. But hopefully this is becoming a little clearer to you, especially with distinct numbers. There's definitely certain numbers that work better than others. Okay? Thank you very much.